Assume that the probability that a 25-year-old lives to an age of 26 based on mortality tables is 0.993. If a $7,000 one-year term insurance policy on a 25-year-old male costs $100, what is the expected value? And we want to round that to the nearest cent. Well, again, we're going to try to build a table. There are only two possibilities in terms of this life insurance. The only thing that's important is whether that person lives or dies. And there's a payout based on that. If the person lives, nothing happens. The insurance company doesn't pay anything. There is no payout. The only payout comes if the person dies. If this person dies, they get $7,000. Whenever we're doing these calculations based on money, we have to consider it costs $100 to get that policy. So you have to figure out what the net cost is. So if you live, you don't get any money, but you've also paid the insurance company $100. So that's a net loss of $100 from your point of view. If you die, that $100 that it cost you to buy the policy still has to be factored in. So you paid $100 to get $7,000 in coverage, so you netted $6,900. It's just like the problems with buying the raffle ticket. You have to adjust for the cost of the ticket. Once you get the net cost, you have to find the probabilities of those things happening. So what is the probability that the person lives? It's 0.993. The probability that a 25-year-old lives to age 26. So the probability they die is 1 minus 0.993, and that comes out to be 0.007. And once you get that, you simply multiply the net cost times the probability. The net cost times the probability. And that fills out the last column in the table, and the last step, as always, is to add up those products. So if you add negative 99.30 and 48.30, you end up with negative $51. So the expected value is negative $51, rounded to the nearest cent.